All right, good morning and welcome to Master Talker online class. In today's video, we'll be solving questions on combination and permutation. Right? So the first question we are going to solve, according to this number, is number 98. It says simplify. Please, if today is your first day of watching my video, please like this video and click that red subscribe button, okay? So that YouTube will notify you anytime we drop a nice video like this. So we'll be talking about combination and permutation. I'll be solving numerous calculations on combination and permutation, right? So we have simplify n permutation r all over n permutation n minus r. Right? Solution. This is a very simple question. So what do you do? If you look at this question, let's see what this will give me. N permutation r is equal to n factorial all over n minus r factorial. Okay? Now look at the other one. N permutation n minus r is what? N factorial all over, then the up minus down. That is n minus, then n minus r, then before you put what? Factorial. So this is equal to n factorial all over. If you clear the bracket, minus, you now have what? N minus n plus r, then factorial, which is what? N factorial all over. N minus n is gone, so I'm left with what? R factorial. So they say we should divide it, that n permutation r divided by n permutation n minus r should be equal to the one here first, n factorial all over n minus r factorial, then divided by, what do we have here? N factorial all over r factorial. So if we do that, we are going to have, if you change divide to times, you are going to have n factorial all over n minus r factorial, then times r factorial all over n factorial. You see that this will take care of this, so I am left with r factorial all over n minus r factorial. So if you put this in terms of permutation, this is going to be the one up, r, okay, permutation, then the one up minus the one down. That is what we, so what are you going to minus down that will give you that? I think it's going to be 2r minus n. 2r minus n. Yes, how did I get the 2r minus n? Watch, this is, if we split this thing, is going to be, watch, if we split this, is going to be r factorial all over r, which is this one, then minus into 2r minus n. Okay, so is it going to give us this? No, it's not going to give us that. So let's check what should be the answer. I think it's a r all over, okay, n minus r. So okay, so if we have this is supposed to be then factorial. So this is supposed to be r factorial all over this, and this is giving us minus r plus n then factorial, which is going to be, okay, yes, which is going to be, if you look at that, it's going to be r factorial. If you arrange it very well, it's going to be n minus r factorial. Yes, I'm very correct. So this is what is, so this is equal to r permutation 2r minus n. So that is the answer for that. So we'll go to the next question, which is question number 99. Question number 99, and it said we should solve for x if 16 combination 4 plus 3x, okay, is equal to 16 combination x. Now if you have this, so solution, you should know that n combination r is equal to n combination n minus r. So if you look at this now, if you compare, you're going to see that what, that r is equal to what, n minus r. So now, provided that n here is n here, so my n is 16, my n is equal to 16, while my r is equal to this, then the other r is the other one. So let us now put it. R for the left hand side means 4 plus 3x is equal to, my n is 16, does not change, minus my r for the right hand side is what, x. This is R for left hand side, R for right hand side. So R for left hand side, R for right hand side. Let me separate it like that. Okay, so if you collect like terms, you're going to see 3x plus x is equal to what? 16 minus 4. So 4x is equal to what? 12. So x is equal to 12 divided by 4, which is equal to what? 3. All right. So we'll move to the next question. Question number 100. So question number 100 said that we should solve for x. Again, we have if 8 combination 1 minus x is equal to the same 8 combination 1 minus 2x. All right. Solution, the same thing we just did now. You should know that your what? Your r for the left hand side is equal to n minus r for the right hand side. So we'll do the same thing. R for left hand side is what? For left hand side is 1 minus x is equal to what? 8 minus r for the right hand side is 1 minus 2x. You have to put this in bracket because minus is powerful. If not, you will fail it. So I have 1 minus x is equal to 8. This I need to give you minus 1 plus 2x. So collecting like terms, I'm going to have 1, this one moving, plus 1, then minus 8 is equal to what? 2x plus x. So everything here is giving me minus 6 is equal to what? 3x. So x is equal to minus 6 divided by 3, which is minus 2. All right. So move to the next question, which is question number 111. Okay. So we don't. Okay. Question number 111. Question number 111 said, in how many ways can the letters of the word hyperbola be arranged with the restriction that the vowels must not come together. Okay. Now, whenever you are told to find this type of question, we cannot get when they are not together. So, but we can get when they are together. So let us, first of all, you need to find without restriction. It's as good as if you are giving a beans mixed with stone to pick. They say, pick out the beans for me. And if you notice that the stone there are very, very small, okay, or let me say rice and stone. Yes, let me use rice and stone. And they say, I need the rice without the stone. We need the rice without the stone. Now, trying to get the rice, start picking the rice is a waste of time. But if you can pick out from the general, from all of them, remove the stone. If you remove the stone, you see that the rice you are looking for is there. So that is what we are going to do here. We're going to get the general first. So we say without restriction. Now, without restriction is the general that I'm looking for. In how many ways can we arrange the word hyperbola? How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. So they are 9. We say that this is 9 factorial. And 9 factorial, you can get the answer, right? Press in your calculator. It means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, this is without restriction. Okay? Now, let's see when they are together. Since it's difficult for us to get when they are separated. So now let's find out when they are together. So we say when the vowels are together. So when they are together, look at how the word will look like. It will now be high, H-Y-P-E is a vowel, H-Y-P-R-B-L. So we now have in bracket of the vowel E is there, O and A. So these are the 3 vowels. So when they are together, it's going to be 1, 2, 3, 4, 5, 6, 7. So I have this one, we count them as 1 when they are together. So you have 7 factorial. Then times, Now, in arranging them inside there where they are, you're going to have, there are three numbers, so I'm going to have 3 factorial. So now this is to get the arrangement when they are together. So now when they are not together, when the vowel when the vowels are not together, is now the total of them, which is 9 factorial minus, now I have 7 factorial times 3 factorial. So now I want this to be in terms of 7 factorial. So this is 9 times 8 times 7 factorial, then times 7 factorial. Then this one is times 3 times 2 times 1. Now 9 times 8 is 56, right? 9 times 8 is, okay, 72. So I have 72. 9 times 8 is 72. So I have 72 in bracket. Okay, sorry. Let's bring out what they have in common. They have 7 factorial in common. So I'm going to have, this time, this is going to be what? 72 minus 3 times 2 times this. Or let me write it first. This is what? 72 times 7 factorial, then times 7 factorial times 6. Now, if you bring out what they have, sorry, minus. Why am I writing times? Minus. So if you bring out what they have in common, they have 7 factorial in common. So I am left with 72 minus 6. So I'm going to have 72 minus 6 minus 6. I'm going to have 66. So 66 then times what? 7 factorial. So that is what you have in the option there. 66 times 7 factorial. So that's for question number 111. Okay, so the answer is ways. So the answer there is B. So we move to question number 118. Yeah, sorry, 112. So question number 112. Oh, there is no 112 here, so I have 103. That one is 101 is the other one. Sorry, this one is now 103. So 103 said if the number one citizen, if the number one citizen of our state is represented by the word governor. Okay, they now say, then in how many ways can the letters or letters of the word representing the number one citizen of our country, CO of our country, be arranged when all are taken. Okay, so now they say that if the number one citizen of our state is represented by the word governor, then in how many ways can the number one citizen, oh my god, let me open here, sorry about that. So in how many ways can the number one citizen of our country be arranged? So now the number one citizen of our country is called the president. So you can tell them that the number one citizen of our country is represented by the word president. Okay, so this is represented by the word president. So let us in how many ways can we arrange president? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we now say uh, the word are arranged in. So president is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 factorial. So get what 9 factorial is. Okay, so get what 9 factorial is as I'm coming. 1 minute. Let me get my power bank so that my phone will not off. Okay, sorry for the distraction. Okay, sorry, let me check if it's charging. Okay, yes, it's charging. So I have that it is 9 factorial as my answer. So get what is 9 factorial, and then that is your own answer. So we move to question number 104. So question number 104 said if n minus 1 permutation 3 is to n permutation 4 is equal to 1 is to 6. Then I say find n. Okay, this is a very simple question. So the first one they gave us is n minus 1 permutation 3, which is what? N minus 1 factorial all over what? N minus 1, then minus 3 factorial, which is n minus 1 factorial all over n minus 4 factorial. So let us get the other one. N permutation 4 is what? N factorial all over n minus 4 factorial. So is to means divide. So which means n minus 1 permutation 3 is to, that is divided by n permutation 4 is equal to what? Let us put it. They say is equal to, okay, 1 divided by 6. So now let me write it. This one gave us n minus 1 factorial all over n minus 4 factorial. Now divided by, this one gave us n factorial all over n minus 4 factorial is equal to 1 over 6. 1 divided by 6 is 1 over 6. So chain division to multiplication, we have what am I saying? We have n minus 1 factorial all over n minus 4 factorial, then times n minus 4 factorial all over n factorial is equal to 1 over 6. Now, so if this now cancel this, we are left with n minus 1 factorial all over n factorial is equal to 1 over 6. Now, do you know that this is n minus 1 factorial all over? N factorial can be written as n into n minus 1 factorial. So it's equal to 1 over 6. So this one cancel this one. I'm left with 1 over 6. Sorry, 1 over n. 1 over n is equal to 1 over 6. So if you turn it around, you see that n is equal to 6. So n is equal to 6 is the correct answer that. So we'll go to question number 105. We are moving. Question number 105. And question number 105 said, in how many ways can a government assign 3 commissioners out of 5 qualified to a certain job? Okay, solution. This is simply the selection of how many people. Yes, letting 3 out of 5. So, and selection is what? Combination. So 5 combination 3 is the answer. 5 combination 3 is what? 5 factorial all over 3 factorial, then 5 minus 3 factorial. So which will give you 5 factorial all over 3 factorial, 2 factorial, which is what? 5 times 4 times 3 factorial all over 3 factorial times 2 times 1, which is going to give me 10. So the answer there is 10, because this cancel this into this is 2. 2 times 5 is 10. So we move to the next question, which is question number 106. So question number 106 said, for what value of x is 18 combination 2x plus 3. You know, you can write combination in this way, is equal to 18 combination x. The same method. Don't forget I told you that what? That arrow in the left hand side is equal to n minus arrow in the right hand side. So arrow in the left hand side is what? 2x plus 3 is equal to what? 18 minus x. So collect items to have 2x plus x is equal to 18 minus 3. So 3x is equal to what? 15. So x will now be what? 15 divided by 3, which is what? 5. So that is that. We move to next question. Question number 107. Question number 107 said, evaluate 7 combination 3 plus 7 combination 4. Right? Solution. So we have 7 combination 3 plus 7 combination 4, which is what? 7 factorial all over 3 factorial, then 7 minus 3 factorial. Right? Plus 7 factorial all over 4 factorial, then 7 minus 3 factorial. So I'm left with 7 factorial all over 3 factorial, 4 factorial, then plus 7 factorial all over 4 factorial, 3 factorial. So if you do that, you are having 7 times 6 times 5 times 4 factorial all over 3 times 2 times 1 times 4 factorial, plus the same thing here, 7 factorial all over 4 factorial, 7 times 6 times 5 times 4 factorial all over 4 factorial times 3 times 2 times 1. Now 3 times 2 times 1 will cancel 6. 4 factorial will cancel 4 factorial. The same thing happened here. So I'm having 35. 35 plus 35, which is equal to what? 70. So the answer there is 70. So we move to the next question. Question number 108. So question number 108 said, don't forget we are solving combination and permutation. So question number 108 said, simplify n minus 1 factorial all over n factorial, then minus n factorial all over n plus 1 factorial. Solution. This is a very simple question. So they said we should have n minus 1 factorial all over n factorial minus n factorial all over n plus 1 factorial. Now, this is n minus 1 factorial all over. N factorial can be written as n into n minus 1 factorial. You can watch my video on combination and permutation. I'll drop the link on the description. Okay, so I have minus. This one can be written as n factorial all over. The denominator can be written as n plus 1 into n factorial. Okay, so this take care of this, while this take care of this. So I'm left with 1 over n minus 1 over n plus 1. So the LCM there is n. The LCM there is what? N into n plus 1. So when this divide this, I have n plus 1 times 1 is n plus 1 minus, when this divide this, I have n times n, I have this. So I'm left with n minus n is gone. So my answer is 1 over n into n plus 1, which is still same as 1 over n squared plus n. So that is that for that. So we move to the next question. Question number 109. So question number 109. So question number 109, we said in how many ways can the letters of the word Mississippi be arranged? Okay, Solution. Now, the word Mississippi, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 factorial all over. M is just 1, so we leave M. I is 1, 2, 3, 4. So I have under it 4 factorial. S is how many? 1, 2, 3, 4. Under it again, 4 factorial. Then P is just 2. I have 2 factorial. So that is just the answer. Very, very simple. So we move to question number 110. So question number 110, we said how many three digits, how many 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5, and 6. Okay, solution. Now, if you want to form 3-digit number, let me say that these are the boxes for the 3-digit numbers that I want to form. All right, you are going to separate them with times if you are solving this. Now, to form the first digit, you know that to form the first digit, any of this number can enter these form digits. So I have how many chances of numbers? There are 6 in numbers, so I have 6 chances of numbers entering here. Now, if I have taken one of them to enter here, so 1 is gone out of this, so I'm left with 5. So and all of them can be here. So I have 5 chances of numbers entering here. If I've taken another one, what is left is 4. So I have 4 chances of numbers entering here. So if you multiply them, you are going to have 6 times 5 times 4. So I'm having 120 ways. Okay, so 120 numbers. So that is very, very simple to do. Okay, so the next question said, question number 111 said, how many even 3-digit even numbers? So that's just the difference. How many 3-digit even numbers can be formed using that? So we want to form even number now and not just ordinary number. Okay, now, and you remember what makes an even number to be even is the last number. If the last number is even, then the word is even. So if you look at here now, how many even numbers do we have here? 1, 2, 3. We have 3 even numbers here. So we have just 3 chances of numbers entering here. So we have 3 here. Now, if I'm picking the last number, how many number is remaining? Out of the 6, I have 5 remaining. Is it not true? 5 numbers remaining. So because I'm picking 1 already. So we have 5 chances of number entering the first one. So because you don't go back, if you have chosen the last one, which will make it even number, you now start from the first one. Okay, so since I've taken 2 now, how many is left? 4. So I have 4 chances of number entering this one. So that is my answer. So you see the way I explained it. So 4 times 5 times 3. So I'm having 60 numbers. Okay, 60 numbers. So that is that. So question number 112. So question number 112 said that if 9 combination x plus 2 is equal to 9 combination x minus 3, then the answer we should find x. The same thing, don't forget the formula that I told you, that r for the left hand side is equal to n minus r for the right hand side. So I have what? X plus 2 is equal to what? 9 minus x minus 3. So if you subtract, you're going to have x plus 2 is equal to 9 minus x plus what? Plus 3. So if you collect like terms, you're going to have that x plus x, this one coming here, is equal to what? 9 plus 3 minus 2. So I'm going to have that x plus x will give me 2x is equal to 9 plus 3 is 12. 12 minus 2 is 10. So therefore, x is equal to what? 10 divided by 2, which is 5. All right. So that is that for that. We go to the next question. Question number 113. Okay, but there is no 113 here. I have 114. So 114 said a 5-man committee consisting of 3 men and 2 women. 3 men and 2 women from 8. From 8 men and 5 women. You now say, in how many ways can this be done? In how many ways can this be done? Right? Solution. Now, what do you do? This is very, very simple. This is just, we want to get 5 men. 5 men committee. That is 5 people committee. And we are selecting, just selection. We are selecting 8 people out of 8 men. Sorry, 3 men out of 8 men. So I have for the men is 8 combination 3. Okay? Times. Then we are selecting 2 women out of 5 women. So we have 5 combination 2. You are done. So this is 8 factorial all over what? 3 factorial. Then 8 minus 3 factorial times 5 factorial all over 2 factorial. Then 5 minus 2 factorial. So this is 8 factorial all over 3 factorial 5 factorial times 5 factorial all over 2 factorial 3 factorial. So I'm left with what? 8 times 7 times 6 times 5 factorial all over 3 times 2 times 1 times 5 factorial. Then times 5 factorial, which is what? 5 times 4 times 3 factorial all over 2 times 1 times 3 factorial. This take care of this. This into this is 2. This take care of this. This take care of this. So I'm left with 8 times 7 times 10. 8 times 7, which is 56. 56 times 10, which is what? 560. So my answer there is just 560. So we move to the next question. Question number 115. Oh, I shouldn't have cleaned that. Question number 155 is almost a repetition. They say that a 5-man committee again, a 5-man committee, consisting of 3 men and 2 women. Okay, just permit me to quickly refill. Okay, so 3 men and 2 women from 8 men and 5 women. Okay, comma. Okay, full stop. Then I say, in how many ways can this be done, comma, if a particular man must be in the committee. Now, this question is very, very simple. So what do you do when you have a restriction? If you have a restriction now, it's very, very simple. We are going to say, sorry, 1 minute. We are going to say solution. Now, for the women, we are selecting, let's do for the women. We are selecting two women out of 5. For the women is what? 5 combination 2 times. Now, for the men, we are selecting 3 out of 5. But one person is already, they have already taken out one person. So what we are selecting is now 2 men is what we are selecting out of 4. You get, because they have already removed one. They say that one must be there. So we've removed that person that must be there. So what we are now selecting is now 4 combination 2. You get that? So which is what? 5 factorial all over 2 factorial. Then 5 minus 2 factorial times 4 factorial all over. How did I get? Sorry, the men are how many? Sorry, this is 8 men. Sorry, we have 8 men. So we are removing 1 man here. So we have 7. But we are choosing, we are supposed to take 3 men. So we are taking 2. So it's 7 combination this. So the women are 5. So we are taking 2 out of 5 women, correct? Then we are taking we have removed one man from here, so we are choosing now. We are supposed to choose 3 men, so we are choosing 2 out of 7 men. So this is 7 factorial all over 2 factorial, then 7 minus 2 factorial. So which is what? 5 times 4 times, okay, before that, we're going to have 5 factorial all over 2 factorial, 3 factorial times 7 factorial all over 2 factorial, 5 factorial. So I'm left with what? 5 times 4 times 3 factorial all over 2 times 1 times 3 factorial. Then times 7 times 6 times 5 factorial all over 2 times 1 times 5 factorial. So this take care of this. This into this is 3. This take care of this. This into this is 2. So I'm left with what? 5 times 2 is 10 times 3 times 7 is 21. So my answer is 210. So 210 is the correct answer for that. Okay? So that is that for that. Don't forget that in the other one we got 560, right? 56 times 10, so 560. Okay? So we go to the next question, question number 116. All right? So they say that, oh God, why should I clean this thing now? Oh, they say that a 5-man committee again, a 5-man committee, I shouldn't have cleaned that, consisting again, consisting of 3 men and 2 women from 8 men and 5 women. Okay, then I say in how many ways can this be done? Look at the restriction now. If 2 particular men, if 2 particular men cannot be in the committee. Okay, now this one is very, very simple. Now solution. Now let us get without any restriction, because I told you whenever you see cannot, it's difficult. So what we get in combination and permutation is when it can. But if it is cannot, you do without restriction minus when it can. So let's get without restriction. Without restriction, which we got that time as 560, but let me repeat it. Without restriction, we are going to have, we are picking normally without any condition. We are picking 3 men out of 8. So I have 8 combination 3 times, we are picking 2 women out of 5. So I have 5 combination 2. So which gave us 560 at that time, if you can remember. Okay, so now let's say the restriction here is that 2 particular men are included. That's what we want to say. So when 2 particular men are must be in the committee, or let me just say are included. Okay, so now if 2 particular men are included, so which means I have removed 2 from the 8, so I'm left with 6. But normally for the women, I'm still having 5 combination 2 for the women times. Then for the men, since I've removed 2 and I'm choosing 3 men, so I'm taking 1 man out of 6, so it's going to be 6 combination 1. Okay, which will give us so if you do that, let me see what it's going to give us. This is 5 factorial all over 2 factorial, 3 factorial times 6 factorial all over 1 factorial, 5 factorial. So this is 5 times 4 times 3 factorial all over 2 times 3 factorial. So this side is giving me 10 times here is giving me 6 times 5 factorial all over 5 factorial. So I'm having 6. So this is 60. Okay, so my answer there is so I have 60 here. So the answer now, when 2 men are not involved, now should not be this minus this. Very, very simple. So you now say when 2 particular men are not included. Let me just use that word, included. So it will now be without restriction, which is 560 minus the restriction 60, which is what? 500. So I think the option here is very, very wrong. So this answer is supposed to be, just press your calculator, 8 combination 3 times 5 combination 2. This is without restriction minus 5 combination 2 times 6 combination 1. So that is how it's supposed to be. Okay? So 500 is the answer there. So we go to the next question. So, and the next question here is question number 117. We said simplify n factorial plus n minus n plus 1 factorial all over, sorry, n minus 1 factorial all over n plus 1 factorial. Okay? So if you look at the solution, this is very, very simple. We have n factorial plus n minus 1 factorial all over n plus 1 factorial. Now this is equal to, n factorial can be written as n into n minus 1 factorial, then plus n minus 1 factorial, then all over n plus 1 factorial. Now, if I factorize what is common between these two people, I have n plus, sorry, I have n minus 1 factorial is common. So if I open bracket, this divided by this, what is remaining here is n plus this divided by this, what is remaining here is just 1. Okay, now all over n plus 1 factorial. Now this is n minus 1 factorial, then n plus 1 all over. The denominator can be written as n plus 1 into n, then into n minus 1 factorial. So just keep removing 1. It's as good as saying 9 factorial is something as 9 times 8 times 7 factorial. So this thing, if you minus 1, you're getting this one. If you minus another one, you're getting this one. You put your factorial. So this will cancel this, and this will cancel this. So I am left with what? 1 over n. So 1 over n is the answer. So go to question number 118. Question number 118 said, 118 said, in how many ways can 7 books, okay, be arranged in a row if 4 books must be placed next to each other. Okay, now placing something next to each other means they are together. So let me say we have 7 books. Let me call it book 1, book 2, book 3, book 4, book 5, book 6, book 7. Okay, let me say that they say that 4 books must be together. Let me say from 1 to 4 must be together. So if they must be together, if you count it, you count them as 1, 1, 2, 3, 4. So I'm having 4 factorial the way they are. Then arranging this one that must be together inside themselves is 1, 2, 3, 4. That's another 4 factorial. So which is what? 4 factorial times 4 factorial. So which will give you, let's check, 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. So I'm going to have 4 times 3 times 2 times 4 times 3 times 2. So I have 576. So 576 is the correct answer there. So we'll go to the next question, question number 119, and which is the last question we are going to solve for combination and permutation. They said here, in how many ways can 7 books be arranged in a row if 4 books must be placed next to each other? Okay, that is what we just solved. So what we just solved now is what? 119, sorry. So for 118, what we solved before was 119, sorry. So 118, they say that if the books must not be together, okay, if the books must not be together, that is for 118, please don't mix it. So if they must not be together, it means first of all we need to get without restriction first, I told that we don't use that not. It's not possible. So what we do is without restriction minus when they are together. So you now say without restriction. Without restriction, we have arranging 7 books normally without restriction is just 7 factorial, and 7 factorial is 7 times 6 times 5 times 4 times 3 times 2, so which will give you 1260 without restriction. Now when they are together, when the books are together, when the 4 books are together, when the 4 books are together, I think we got it as a 5 7 something. Don't forget that that's where I say that it is 4 factorial times another 4 factorial, which we got at 576, right? So now when they are not together, when the 4 books are not together, will now be without restriction, which is what? Which is 1260 minus 576, which will give you 1260 minus 576. So I'm going to have 684 ways of doing that. So thank you very much for watching. Please don't forget to like, share, and subscribe. Bye bye.